Time, a concept so familiar yet so elusive, shaping the foundation of how we perceive the universe. It's a one-way road, or so we thought. But in groundbreaking quantum experiments, scientists have stumbled upon a phenomenon that might defy our conventional understanding: negative time. Yes, time flowing backward, like rewinding a cosmic clock. This isn't just science fiction. It's quantum physics pushing the boundaries of our reality. To understand how such a discovery came to light, we need to dive into the strange and surreal world of quantum mechanics, where particles defy logic and common sense. Unlike the predictable laws governing our everyday world, the quantum realm operates under its own rules, where uncertainty reigns supreme. Particles can exist in multiple places at once, behave like waves and solids simultaneously, and even change based on whether they're being observed. It's here, in this quantum theater, that time as we know it starts to lose its grip. In these cutting-edge experiments, researchers observed particles behaving in ways that suggested time wasn't just moving forward. Using specialized setups involving entangled particles, pairs of particles mysteriously connected no matter how far apart they are, scientists noticed something astonishing. When one particle's state was altered, the corresponding change in its entangled partner seemed to ripple backward in time, as if the effect happened before the cause. This wasn't just an illusion or an error in measurement. It was evidence of what some call retrocausality. Imagine this. You flip a switch to turn on a light, but instead of the light responding after your action, it turns on before you flip the switch. In the macro world of our daily experience, such a scenario is impossible. Yet, in the microscopic universe of quantum particles, this backward flow of information seems to not only be possible, it's observable. The phenomenon of negative time has profound implications for how we understand causality. If the past and future can interact in the quantum realm, it forces us to rethink whether the arrow of time, a concept as old as Newton, really only points in one direction. This discovery is akin to adding a new dimension to reality. Just as Einstein's theory of relativity revealed that time isn't absolute but flexible, bending with gravity and velocity, these quantum experiments suggest time may be a two-way street in ways we've barely begun to comprehend. But how is this even possible? To grasp it, let's consider time not as a flowing river, but as a construct of perception, a tapestry of events that we stitch together in one direction. In quantum physics, time may be no more fundamental than space. If space can be traveled in any direction, why not time, at least on the smallest scales of the universe? Critics argue that the evidence for negative time might just be artifacts of the experiments themselves, mere quirks in the delicate quantum systems. But the consistency with which such retrocausal effects appear makes them harder to dismiss. Beyond the laboratory, such findings could offer an explanation for some of the deepest mysteries in physics. Could the phenomenon of negative time be the missing link that unifies quantum mechanics with Einstein's relativity? Could it explain why certain physical processes appear finely tuned to allow for the emergence of life and complexity? The implications of these discoveries stretch far beyond theoretical physics. Technologies built on quantum principles, quantum computing, cryptography, and perhaps even time-sensitive communications, might one day leverage this backward flow of causality. But ethical and philosophical questions also loom. If time is not strictly linear, how do we grapple with concepts like free will and predestination? Could events in the present be manipulated to alter the past? Or is there a safeguard we don't yet understand, limiting negative time to the quantum world? One thing is certain: these discoveries deepen the mystery of what time truly is. The concept of negative time challenges the very fabric of how we perceive existence, leaving us with more questions than answers. Yet, isn't that the essence of science? To unravel one mystery, only to uncover 1,000 more? Scientists are standing on the edge of a paradigm shift, one that might forever change our understanding of time, causality, and the universe itself. It's not about whether time flows backward. It's about what else is possible when it does. So, are we on the verge of rewriting the very laws of reality? And if time isn't as linear as we thought, Could this discovery pave the way for technologies and ideas we've only dreamed of? Negative time might sound strange today, but tomorrow it could redefine the nature of existence.